Yesterday, we started integration by parts. When we apply the integration by parts, we decided u and dv first. And then one function was differentiated. While the other function was integrated. The formula went like this. So integration by parts was about the integration, about the product function. The formula went like integration u dv is uv minus integration v du. Let's continue with the example. The problem is evaluate integration sine inverse of x dx. If you look at the function, then this is not a product function. But we can regard this one as sine inverse times 1. And then in that way, we can say that that is an integration, the product function. So we put sine inverse of x as u, and then dv equals 1 times dx. After we decide u and dv, you think about the derivative of u, then that is 1 over square root of 1 minus x squared dx. And v is a differentiation of the integration of 1, which is x, right? So we start with this, and then formula went like this. Integration sine inverse of x dx equals multiplication of u and v, which is sine inverse of x times x minus integration x over square root of 1 minus x squared dx. Then what we can observe from the second term is a numerator x is a 1 less degree to 1 minus x squared. So if we use the substitution method, then we can do integration. Let t equals 1 minus x squared. Then when we differentiate, dt equals minus 2x dx. So we are getting this part. So what we have to do from here is we divide by minus 2 on both sides. Then x dx equals minus 1 over 2 dt. So integration x over square root of 1 minus x squared dx equals integration for this part is minus 1 over 2 dt. So minus 1 over 2 times dt. And for this part, that is 1 over square root of t. Right? So that is integration, that is minus 1 over 2 integration 1 over square root of t dt. So that can be written as minus 1 over 2 integration t to the minus 1 over 2 power dt. So we will apply the straightforward integration formula. So t to the minus 1 over 2 plus 1 over minus 1 over 2 plus 1. So that is 1 over 2, right? Minus 1 over 2, and the denominator is 1 over 2, and the numerator is t to the 1 over 2. And then what you will notice will be this one, 1 over 2 and 1 over 2 in the denominator are the same. So they will cancel each other. And here I had to put plus c because that is indefinite integral. So we have minus square root of t plus c. T was 1 minus x squared. So finally, we are getting minus square root of 1 minus x squared plus c. So this part is about the integration of x over square root of 1 minus x squared dx. So we finally get the answer, final answer, x times sine inverse of x plus square root of 1 minus x squared plus c. You may ask me why that becomes plus square root of 1 minus x squared. That is because minus and minus will make plus. Any question? Let's do a similar pattern of problem. The problem is evaluate integration of natural log of 5x plus 2 dx. Again, this is not a product function, but we can view this as a natural log of 5x plus 2 times 1. And whenever we have natural log and we apply partial integration by parts, then we put u equals natural log of 5x plus 2. And dv equals dx. And so du equals what? 1 over input, which is 5x plus 2. And you have to differentiate what's in the input. So it becomes 5 because of the chain rule. I will not go through the details. And then dx. And if you integrate 1, then that is x. So v becomes x. Let's rewrite based on the integration by parts. Then integration, natural log of 5x plus 2 can be written as x times natural log of 5x plus 2 minus integration, this one times this one, v du, so 5x over 5x plus 2. Here we have a problem because when you look at this fraction, the numerator is not the differentiation of the denominator. So we cannot use substitution method, but what you notice is a 5x and 5x are the same. So we will alter the fraction 5x over 5x plus 2 into 5x plus 2 minus 2 over 5x plus 2. Just basically, let's write the same in the numerator and make some small adjustment to make the numerator 5x. Then we realize that when we separate that, that becomes 5x plus 2 over 5x plus 2 minus 2 over 5x plus 2. Right? So we can rewrite the fraction as 1 minus 2 over 5x plus 2. So that is all about the fraction. Let's go back to the integration here. Then that is x natural log of x 5x plus 2 minus integration based on this information about this fraction. We can rewrite that as 1 minus 2 over 5x plus 2 dx. Let's rewrite this x natural log of x, natural log of 5x plus 2 minus integration 1 dx plus integration 2 over 5x plus 2 dx, because minus minus will make plus. So this becomes x times natural log of 5x plus 2. If you integrate 1, then you will get x plus integration 2 over 5x plus 2 dx. So all you have to do is integrating 2 over 5x plus 2. So we will work on this. T equals 5x plus 2. Then we have dt equals 5 dx. So integration 2 over 5x plus 2 dx equals integration of 2 over t. And from here, dx equals 1 over 5 dt, right? So times 1 over 5 dt. So this one is a 2 over 5 integration 1 over t dt. So what is that? That is 2 over 5 natural log of absolute value of t plus c. And then we can say that that is 2 over 5 natural log of t was what? T was absolute value of 5x plus 2 plus c. So we worked out this part. So the final answer for the question is x times natural log of 5x plus 2 minus x plus 2 over 5 natural log of 5x plus 2 plus c. Any question? Yes, I think when you do integration for that, the 1 over x, I think you should put natural log of absolute value of x. Yeah, that's correct. So that is from the integration formula. Let's do just one more problem in this section. Evaluate 13 z cubed times e to the z dz. When you look at the pattern of the product, what you realize is if you differentiate z cubed, then you will have 1 less power, so z squared, which is relatively simpler. So we will put z cubed as u, but when you think about e to the z power, e to the z power, when we integrate, that becomes just e to the z. So just it doesn't make things more complicated. So whenever you see sine or e to the z, then it tends to be here, du, dv. And if we differentiate this, then we have 3z squared dz. And then that is uv minus integration v du. The given integration can be written as 13 integration z cubed times e to the z dz. So u times v is a z cubed minus z cubed e to the z minus v du integration v du, which is e to the z times 3 times z squared dz. So that is z cubed times e to the z minus 3 times integration e to the z times z squared dz. So u equals z squared and dv equals e to the z dz. And just the same pattern with the lower degree, but we have to repeat it because we produced a little bit simpler but same pattern of the problem. So v is e to the z and du equals 2z dz. What you can imagine is we have to repeat it one more time. So this is z cubed e to the z minus 3 open bracket z squared times e to the z, z squared times e to the z minus integration e to the z times 2z dz. So this one is z cubed e to the z minus 3 times z squared times e to the z minus, we can pull out that number here, integration e to the z times z dz. So we have to think about this part. We apply the same method, then we will eventually get something. So we are focusing this part, then u equals z and dv equals e to the z dz. And when we integrate, that becomes e to the z. If we differentiate du, then that is dz. So it'll be just the last step. What do you mean? Where did you see 13? Yes, 13. Actually I dropped it. Sorry. So the I had to carry 13, but I dropped it. And so the from the second line, and so forget 13 for a while. After we calculate this part, we will multiply by 13 to do every term. Thank you for pointing that out. All right, so we have z cubed e to the z minus 3 times z squared times e to the z minus 2 times z times e to the z minus integration e to the z dz. Right, but this one is just e to the z. So let's write that down again. Z cubed e to the z power minus 3 open bracket z squared e to the z power minus 2 times z times e to the z minus integration of this one is e to the z, right? Let's work from inside. So we will think about this part, then z cubed times e to the z minus 3 times z squared e to the z minus 2 z times e to the z plus 2 times e to the z, right? So that becomes z cubed e to the z minus, we multiply by minus 3 for each term. Then that is 3 times z squared e to the z plus 3 times 2 is 6 minus minus is 6, the plus, so plus 6 z times e to the z minus 6 e to the z plus c, because 3 times 2 and minus times plus is minus. We have only one more step. The last step is just multiplying by 13 to the entire thing, because integration 13 e to the z times z cubed dz equals 13 times integration e to the z times z cubed dz. Right, so that is 13 times z cubed e to the z minus 3 z squared e to the z plus 6z e to the z minus 6 e to the z plus c. We don't have to multiply by 13 to c because c is any random number. So in the end, we are getting 13 z cubed e to the z minus 39 z squared e to the z plus 78 z times e to the z minus 78 e to the z plus c. And that is the last question in this section. Any question? The next section is about trigonometric integrals. The first question is evaluate integration cosine cubed x dx we can integrate cosine. There is a formula that was signed, but we cannot integrate cosine cubed easily. So we need some trick. The way we see this cosine cubed will be cosine cubed of x is cosine square root of x times cosine of x. Why do we see the cosine cubed as cosine squared times cosine? The reason is, if you remember the Pythagorean formula from trigonometry course, then that goes like cosine square root of x plus sine square root of x, that equals 1. And cosine square root of x equals 1 minus sine square root of x, right? And then the expression will be the combination of sine and cosine. And we know that when we differentiate sine, we get cosine, which means maybe we can use a substitution method. Let's go back to the problem. Cosine cubed of x dx. That can be written as integration cosine square root of x times cosine of x dx. So cosine square root of x is 1 minus sine square root of x times cosine of x dx. So let's use substitution method by putting u equals sine of x, then du equals cosine of x dx, right? Then the given integration can be written as a polynomial form, like integration 1 minus u squared cosine x dx is du. So that is u minus u cubed over 3 plus c. So u was written as sine of x. So sine of x minus u cubed is sine cubed of x over 3 plus c. As I said, you are learning really many techniques in integrals, and you have to remember the pattern of the integrals and the associated technique. What you have to remember is you have sine or cosine, and whatsoever that is, if that has a odd degree power, then you usually use Pythagorean formula to make things combined, to make things combined with cosine, both cosine and sine. And one of them must have degree 1. The next pattern of the question, but this is the similar technique. Actually, same technique. Integral sine to the 5th power x times cosine square root of x dx. You see that sine has odd degree power. Then what I said was you will think about the Pythagorean formula. And then you realize that sine square root of x can be written as 1 minus cosine square root of x. Let's just start with sine fifth power x times cosine square root of x. Then when we relate this one with this one can be sine to the fifth power can be expressed as sine to the fourth power x times sine of x times cosine square root of x. So sine to the fourth power of x can be written as sine square root of x squared times cosine square root of x times sine of x. And then we put this one instead. Then this part can be converted into cosine related things, and we have only sine x. So if we put u equals cosine, then du will be sine x dx, right? So we can use substitution method. So sine square root of x is 1 minus cosine square root of x times cosine square root of x times sine of x. I dropped squared here. You can do FOIL, but I will just use the formula. A minus b squared equals a squared minus 2ab plus b squared. So the first term squared is 1 minus 2 times cosine square root of x plus the second term squared is cosine to the fourth power x times cosine square root of x times a sine of x. So we will use the substitution. Which make u equals cosine of x, then we have du equals minus sine of dx. So we have to be a little bit careful. So integration sine to the fifth power x times cosine square root of x dx equals for this part that becomes integration 1 minus 2 times u squared. Instead of cosine, we will use just a u plus u to the fourth power. And we have cosine squared here, just all three are multiplied. So cosine squared is a u squared, and sine x dx will make du, but that is minus du. Then that is minus integration u squared minus 2 times u to the fourth power plus u to the 6th power du. What I did was just a distribution. So that becomes minus u cubed over 3 minus 2 times u to the 5th power over 5 plus u to the 7th power over 7 plus c. And u was cosine, so minus, open parenthesis, cosine cubed x over 3 minus 2 over 5 cosine to the 5th power x plus cosine to the 7th power x over 7 plus c. We don't like a parenthesis, so we put minus cosine cubed x over 3 minus will make plus 2 over 5 cosine 5th power x plus times minus will make minus cosine to the 7th power x over 7 plus c. Any question? Next Tuesday, we will learn about the different pattern, which doesn't have odd degree. When we have even degree, we have to use half angle formula. Next Monday, we will meet in person. You will be engaged in problem solving activity, which will be essentially an open book quiz. Let me remind you of the regulation of open book quiz. In open book quiz, you can talk with other people and you can discuss the problem, but you will write the solution independently. You can look at your own note, but you will not open any electrical device and you will not Google search anything. So it'll be just a paper and pencil version of activity. And the range will be just the things we've been learning for 2 weeks. So don't forget to come to the class because every Monday we will start to see in person for open book quiz because I have to collect it and you will discuss the problem with others. And if you are struggling, then you can also find a good classmates to form the study group. And that is another purpose to do this kind of activity. So be well prepared and also talk with other people and know each other to discuss the problem and study together. Okay. Then if you don't have any question, then we will see in person in Mathematical Sciences building in 4th floor on Monday. Maybe I will upload the recording within 30 minutes from now. It should there should be some processing time. It depends on when it is processed, but it usually happens within 30 minutes. So I will upload it as quickly as possible. Do you have any other question? You can ask me any question. Otherwise, I am ending the class. You can leave. The what we covered during this semester, just the all the materials I covered for 2 weeks. All right, see you Monday. Have a good day.